Okay, so welcome back. Today we're going to take the next step in our discussion, our continuing discussion of how to capture what you see here in our C# Windows Forms Visual Studio application, where we are capturing video that is streamed from our smartphone over Wi-Fi, and we're capturing it on our computer and displaying it here. And we're going to take the next step in that discussion where we are going to do image processing on each frame of this streaming video. And in this application, we are going to give the user the option of not only filtering or doing image processing on each frame, but also choosing whether we use our computer's CPU or the graphics processing unit, the GPU, to do the processing a whole lot faster. So here is live streaming video coming into the computer, into our application, and I have got a checkbox here set to say, hey, I want to process this using the GPU in real time. And what I'm going to do is click this checkbox and say I want to process the image, and you can see in real time it is applying a filter using the GPU, and you can see it is giving us a real-time video and processing this. And you can see here that we are monitoring our GPU, and we're using our NVIDIA CUDA device. And here we are in Task Manager showing that as we started this up, now we are using the GPU to do the processing. And what I can do is I can pause this, and you can see suddenly our GPU CUDA cores are not doing any more processing. So you can verify that yes, we're using the GPU to process this image in real time. Now I can also do the same thing, and I can deselect GPU, and it will continue processing. And you can see it will slow down quite a bit because now it's using the CPU and it's going down to 5 frames per second. And when I select the GPU, it will now go back up to around 60 frames per second that we've got it set at. So we're going to show you how to develop this application, C# Visual Studio Windows Forms. And we also have the ability here to select, using this numeric up-down control, if we have multiple cameras, we can select which camera we want to use. And we can pause the capture. And we can also print out some information about our camera we've talked about in previous videos. Some of the properties of our camera, what cameras are available. So let's take a look at our C# Visual Studio Windows Forms application, see how we can build this. Okay, so here we are in our simple C# Visual Studio Windows Forms application. And again, we've covered a lot of this in previous videos. We've talked about, for example, how to process a single image using your GPU and EMGU-CV, OpenCV. We've also talked a lot about capturing streaming video and how to do that, how to set it up. And what we're going to do in this video is we're going to bring all that together so that we can do image processing on streaming video using our GPU or our CPU. So here's our application, very similar to the format I use for most of my applications. We've got documentation. We got regions here with documentation on what this application does, some to-do items, a list of parameters we'll talk about, and then our main form 1, initialized component, and some other stuff, and then we've got methods and event handlers. So to start out, the first thing we need to do, as we've talked about before, is we need to make sure we have emgu.cv and also emgu.cv.cuda installed so that we can access our NVIDIA CUDA based GPU. So we've talked about this before, but we'll briefly go through it again. Tools, NuGet Package Manager, manage NuGet packages for solution. We have to make sure we have installed emgu.cv by EMGU Corporation, emgu.cv.bitmat by EMGU Corporation, and also emgu.cv.runtime.windows.cuda. In other videos, we've just did runtime.windows, but now we're going to be accessing our CUDA GPU. So we need this library by EMGU Corporation. Make sure you got that set up. Also, we talked before, we can't have any CPU connected up here in solution platforms. And we showed you how to set it up so it's, in our case, only x64. That's very important. So first, we're going to look at the UI, very similar to what we did previously. Our main control here is a picture box, and we've got it set in zoom mode to make sure that whatever size streaming video is coming in will fit inside this. We've got a couple check boxes here that allow us to select if we want the image to be filtered by either the GPU or the CPU. And also we can select if we want the GPU to be doing the image processing. I've also added something here you may not need. I've got 2 cameras and 2 different applications for capturing, and I can select either of those cameras. If you don't have 2 cameras, you don't need all this, but this is basically what's called a numeric up-down control, and I can just scroll 0, 1, 2, 3 or whatever to select whatever camera I want. Again, you may not need that. We've got a label to give us the real-time calculated frames per second, how many frames we get every second coming from the camera. Of course, we've got our start button. We've got a pause button that will pause the streaming video. We've got the ever-present text box to give us feedback on how things are working. And also, in our case, we're going to be getting properties of the camera and what cameras are available and that kind of stuff. We're going to be showing that in this text box, and then an exit button. So that's about it for the UI. Very simple. I'll assume you know how to drag and drop those components, and then double click on each of these buttons to get the event handlers. So now that we've got EMGU, CV, and CUDA installed, we're going to need our using emgu.cv, emgu.cv.cuda, and emgu.cv.cvenum. Also using system.management, because we're going to be accessing devices, as we showed in previous videos, how to find out what devices, like what you will see in your device manager in Windows, how to access those, see what's available, so we can look and see, for example, what cameras are available, and then system-windows.forms. So as we said before, docs, to do, and then parameters. So briefly, I'll go through the parameters. As we said, we can either run the streaming video or pause it. So we've got a Boolean stream video. We're going to default it to false, and stream paused is false. So that's going to be used in determining if we want to show the streaming video or just pause it. I have defaulted the camera index. Each camera can be accessed by an index number. We talked about the 4 static integer camera index equals 1. In my case, in yours, it may just be 0 if you've only got 1 camera. Double frames per second old and double FPS. We're going to use this as we've done before in calculating real-time frames per second grabbed from the camera. In my case, it's going to default to 30. We're going to reset that up to 60 because we're going to be using the processing, and it's going to slow things down maybe if we use the CPU. So this is going to allow us to calculate real-time frames per second. And also this date time values and time span will allow us to calculate how many seconds between frame grabs, which allow us to calculate frames per second. So we've got a date time, last, and now, and then time span is going to be the difference between the last and now, which tell you what the present time is when we capture a frame, and the previous time, and then the time span is going to be the difference. I'm defining a new video capture device, public video capture. This is the emgu.cv video capture device. We're going to call it capture. We're also going to resize this incoming video frame size. In our case, it defaults to 640 by 480. We're going to resize it using the system-drawing.size. We're going to call it frame size as new system-drawing.size 1920 by 1080, so we can put it into our picture box. You don't need to do that, but we're just going to show you how to do it. So those are the parameters, very straightforward. Again, Form 1, initialize. We are defaulting the checkboxes to being unchecked for whether we want the GPU and the filter. Those are going to be unchecked. First thing we're going to do is go out and say, okay, before we start this, let's get a list of all the cameras that are available. So we're going to run this get cameras method. We're going to talk about that. You don't need to do that, especially if you only got one camera. It's just going to be a default camera index of 0. And then we're going to, once we've got those, this is going to print out in our text box the available cameras and then do a carriage return line feed so we can add more information. And the next thing is going to be when the user presses this start button. So the event handlers are the start button. An event handler, each time the capture device has grabbed an image, it's going to give us an event, as we talked about before, and then we can do the processing. And then we've got a button stop, and we've also got a timer 1 tick. The only thing this is going to do is calculate frames per second, so that we don't, we could calculate frames per second every time we grab an image, like 60 frames per second, but that means the display on the UI of the frames per second is going to be bouncing all over the place. So here I'm just adding a timer, a system timer, that operates a lot slower so they can update the user interface with the calculated frames per second on a slower, more easy to look at basis. You don't have to do that, but we'll just show you can do it. The button start, the first thing we're going to do is instantiate our capture device. Now, you can also use as your capture device a file, a movie file, or some sort of video file. We're not doing that here, but here you can say capture is new capture device and feed it the path of, in our case, is MOV file, a movie file, and use that as the incoming video. What we're going to do is we're going to pick one of the cameras that are available and instantiate that as our new video capture device called capture. And in my case, we're going to grab whatever's in the numeric up down dot value, convert that to an integer, and that is our index, our camera index. It might be 0, 1, 2, depending on what cameras you have. And then feed that to this video capture class as the index, and that will instantiate our new capture device, which will be that camera. Now we also, in my case, we're able to change the frames per second that this camera is feeding out onto the video stream. And we're going to change it to 60 frames per second from the default, because if we're going to be doing any filtering using the CPU, that will slow down this capturing a lot. It's not going to be a big deal when we use the GPU, but just in case we use the CPU, I'm cranking this up to 60 frames per second. So if we use the CPU to do the filtering, it will still give us a reasonable frames per second. So capture.set, emgu.cv, cvenum.capprop, or captureproperty.fps, comma 60. And I talked about this in the other video about accessing and setting and getting camera properties. The next thing is we're going to run a method that we developed called get camera properties. We talked about this in our other video. We're not going to go into much detail. You don't need to do this, but it's just going to display whatever available camera properties, like width and height of the frame and that kind of thing. It's going to display that in the text box. We'll talk about that later. Also get available backends, which just tells us what is available in this system for our video in terms of compression and decompression, that kind of thing. What are the backends available to process this video? Again, you don't need to do that, but we'll show you a little bit later what those methods are. So we've basically just set up our capture device, told it to go to 60 frames per second, and now we're just doing what we've done before. We're saying, okay, now our Boolean stream video is true, start streaming, and we are subscribing our capture_image grabbed event, which you see down here below, which is the event handler, and we are using the video capture.image grabbed event that is sent out anytime this capture device grabs an image coming from the video stream. We're just subscribing to that event. So anytime it grabs an image, we can run our event handler and process it. And then we're doing capture.start to start the stream, and we're all set. We are enabling our timer to update the UI, and then we are just for visuals, we are disabling the button start. Since we just started it, we don't want the user to click on it again. We want it to click on the pause button. So that's it for the button start. You just set everything up, start the capture, and we're ready to go. And now all the control is going to move over to this image grabbed event handler. The capture device is going to say, hey, I grabbed an image, and now we're going to process it. So if we have stream video set to true and we're not pausing the video, then we're going to go through and do this. And basically it's going to process the image. In our case, we're going to do a simple blur on each image in the video stream, and we're going to either do it with the CPU or the GPU. So all of this is going to be just to decide, are we going to do GPU processing or CPU processing? So the first thing, we're going to define 3 EMGU-CV or OpenCV mats, which is a matrix defining a frame. And we're going to say our incoming frame is a new mat, our processed frame is a new mat, and then we're also going to have a resized frame, which is taking the default frame, maybe 640 by 480, and resizing it to maybe 1920 by 1080 or whatever. So we're just defining these mats. And we're also defining the date time now when the image is grabbed. We're saying here's the date time now that we grabbed the image, and then we're comparing it to the last time an image was grabbed, taking that difference, and that is our time span, TS, and that will tell us how many seconds between subsequent frame grabs. So then we can later on calculate frames per second. And then we are now taking our now, and it is becoming the last, so that next time we grab a frame, we will have a new value to compare with. So now we figured out frames per second, and we can also go in and adjust image brightness and contrast and whatever. We're not going to do that right now, but just to show you, you can do that. And what we're going to first do is retrieve the grabbed frame. Now, in this image grabbed event, the capture device has already captured the event. It's already been grabbed. So all we have to do is access it. We don't need to grab it. We've talked about that before. We just need to access it. So what we're going to do is we're going to do a capture.retrieve, which decodes and returns the grabbed frame. And we are going to put that into this matrix called frame. And if that is successful, we will get a Boolean from this capture.retrieve. We'll get a Boolean that says, yes, it was successful. If that was successful and we've got our new frame, if check filter is checked, if the user wants to process the image, then it's either we're going to do it by GPU. If check GPU is checked, we'll do this. Otherwise, we will do it with the CPU. So we talked about this before. If we're going to process an image with a GPU, we're going to use this GPU mat, which is like an EMGU-CV or OpenCV mat or matrix, but this is on the GPU. And we talked about in previous videos, especially in the video on processing an individual image with your GPU. So I encourage you to look at that. It explains what the process is. But we're defining a frame that is on the GPU, that is the incoming frame, and also another frame on the GPU that is the processed frame, the result of the GPU doing the blur, and we are defining those two. And as we said before, we have to take that GPU frame, the incoming frame, send it over the PCIe bus using this GPU frame.upload, and we're uploading this frame from the CPU in our main memory. We're uploading it, and it's becoming our GPU frame. And then we are using a CUDA invoke. As we talked about before, instead of CV invoke, it's CUDA invoke since we're doing it on the GPU. And we're invoking this bilateral filter to blur the image. And the input image to this bilateral filter is the GPU frame. The output is the GPU processed frame. And we are using these parameters, which are kernel size, color, and sigma spatial. Now you can go through on your own and look at this, what this bilateral filter does. I just picked these numbers. It seems to work nice for the filter. We're not going to talk a lot about that, but you can see it's very simple. It just invokes this filter method, so it blurs it on the GPU, But of course, now we have to download the process, the result. We have to download this GPU process frame. And on our CPU side in main memory, it's going to be now called process frame coming from the GPU. Now, if we don't want to do it on GPU, we have this else, and we'll just do a CV invoke, an OpenCV invoke, the same bilateral filter, but now it's working on the CPU side, the frame, the process frame, and we're using the exact same values for the bilateral filter. Whether we're using GPU or CPU, at this point, the resulting frame from either device is called process frame. And now what we can do is resize that process frame and call it resized frame. And we're going to use this frame size we defined before, 1920 by 1080. So at this point, we have done the processing and we've got this resized frame, which is processed and resized. If we didn't want to do the filter, if check filter is not checked, all we do is we take the incoming frame and resize it as we did previously, and now we've got our resized frame. So at this point, we've got the resized frame, which is either filtered or not filtered. If it was unsuccessful in retrieving this frame, then it will just do nothing. We'll just ignore it and go on to the next frame. You can put an error message, whatever you want. And then, now that we've got our resized frame, we can try to convert it to a bitmap and put it in our picture box. So as we did before, we just take this resized frame, which is either from the GPU or the CPU, convert to bitmap, and make that as the picture box 1 image. And if that fails, we'll just ignore it and move on. Now that we've done that, we can dispose of our frame, our process frame, and our resized frame, and it's already been displayed. We can go on to the next one. So that is the core of this application. We grab the frame, we process it by either the GPU or the CPU, and then we display it. Very straightforward. Button stop, click. This is going to actually pause the video, which you may not even need, but button stop, click, when we press the pause button, if stream paused is false, then stream video equals false, timer 1 enable equals false, stream paused equals true. We're now going to change it to true, and then the button stop text is going to be resumed. So this just allows us to pause the video and whenever we want, restart it. Else, if the stream is paused, then we're going to resume it. So stream video equals true, timer 1 enable equals true, stream paused equals false, and button stop.txt equals pause. And then timer 1 tick, all that does is calculate and display the calculated frames per second in our label. So the last thing we have to do is look at these methods that basically get the camera properties and the back ends. Again, you may not need these. I'll just show you what they do. And we also have the calculate FPS. So get cameras. We talked about this before. I'm not going to go into detail. We do a management object searcher, select all from Win32PNP entity where it's either an image or a camera. And for each device in that result, we're going to look for the device caption and append that to the text box, right? So it's just finding out all the available cameras and appending the names to the text box. Also, get camera properties. We talked about this previously. For each var prop in enum, get val's type of cap prop. Prop val is capture.get cap prop. And you can just pause the video and type those in. I'm not going to go through those. You may not even need them. And then available backends, defining array of backends. CV invoke writer backends for each backend. Append the name. And we've done this before, calculate FPS. If the time span total milliseconds is greater than 0, then calculate the time span in total milliseconds times 0.001. 1 over that is the frames per second. Then we have a little filter here that makes it so it's not bouncing around a lot. I'll leave you to go through that. We've talked about that before. But that's about it for this application. It's really straightforward. And what's nice is they've made it so easy to do the GPU processing as long as you know how to do it. You have to define frames for the incoming and outgoing frame on the GPU, and then just upload your frame to that GPU frame, do the calculation, and then download it, and you're all set to go. So really nice and easy. So I hope that helps. If you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications. But most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.